In this video, I will show you how to create the circle class that was discussed in the practice exercise and the lesson notes. Now we are creating an entire class, so we want to think about some things before we start typing the Java code. The main things we want to think about with the class are, what are the attributes? Those are the variables containing data values contained within the class that will be used by the methods of the class. Now we also want to consider, what are the methods that we need? How many constructors? What's the parameters coming into the constructors? Based on the attributes we have, how many assessors and modifiers do we need? And then what are the other utility functions? So when we looked at the circle class, we realized we only needed one attribute, which was the radius. Everything else about a circle is calculated from the radius. So that's the only attribute we need. The constructors we determined that we wanted was a null constructor, which receives no parameters, a copy constructor, which can create a copy of another circle object that's passed into us, and then a constructor where we set the value of the radius. There's only one attribute, so we only need one assessor and one modifier. And the utility functions will be the calculations that are performed from the radius to determine the various values of a circle. So now with that in mind, let's start creating the circle class. We start with the public scope and the class keyword. The class keyword tells the compiler that this is a class and we are creating the circle class. So we'll name it appropriately, so as we refer to it, we'll always know what it is. And I'm always going to do my end brace just so I don't forget it. This is just a habit I do. You don't necessarily have to do that. It's just that I want to make sure I don't forget the end brace. I'll put in some comments as I work so you can follow along. So typically, what is put first in a class are the attributes. So now what's the attributes in the circle class? Just the radius. What's its value? Well, some radii can be a decimal value. We determined in the practice exercise that we would use integer values. So we declare a variable of type int, and we'll call it radius. Might as well call it what it does. Okay, the next thing are the constructors. Constructors always have a public scope so that a user desiring to create an object is able to do so. Constructors have no return value whatsoever, and their name is always the name of the class. So here's our null constructor, which receives no parameters, but we still need to specify the parentheses. Since it's a null constructor, it doesn't do anything, so we won't have any code in it. Now we'll have another constructor, which receives an integer value, which we'll call r, which sets the radius. Now you may wonder, well, why did I call the parameter r? Why didn't I call it radius? Because that's what it is. It's the value of the radius. Because then when we went to set the attribute, we'd say radius equals radius. Compiler would be confused by that. It doesn't know which radius you're talking about. That's called an ambiguity error, and that would be a compilation error. So you always want to make sure that any variables that you are creating that are the values passed as parameters are always differently named than any of the attributes that you're going to be referring to in that method. All right, then the last constructor we said we were creating was a copy constructor, so it receives a circle object. Copy constructors, if you look at your text, are basically setting attribute values. We only have one attribute, which is radius, and we're setting our current radius to the radius that is in the circle object. The object is C, and we refer to it by dot, the same way we would call a method, but here we are getting the radius. We can do that here because any methods of this class can refer to the attributes of this class. So even though we're receiving a different object, it is an object of the same class. So this method can refer directly to the radius data value contained in this object that we are receiving as a parameter. Okay, next are our assessors. We only have one attribute, so we only have one assessor. Assessor, remember, is what receives the parameter value and gives it back to the user. So the return type is going to be the same data type as the attribute. It's fairly standard in the industry to have assessors start with the word get, and what are we retrieving? The radius. So the name of the method is getRadius. No parameters necessary. We're not sending anything into the class. We're only receiving a value from the class, but we still need the parentheses with no value inside of them. And assessors are simply a one-line code function which uses the return keyword to return the value of the attribute to the user. All right, now we have a modifier. We only have one attribute, so we only have one modifier. The return type for modifiers can vary in the industry. I typically have modifiers which return no value, so it would return a void. Some people return the previous value of the attribute that's being changed by the modifier. So you can do it whichever way you want. I prefer, if you're going to do that, that's having a modifier combine the functions of an assessor and a modifier. Let the user decide if they want to do that. So my preference is not to return a value, but you can do it whichever way you like. Modifiers typically begin with the word set. So we'll do the same thing. And what are we setting? The radius attribute. Now, modifiers receive a value as a parameter. It receives the value we want to put into that attribute. So the data type of the parameter has to be the same as the data type of the attribute. It's an integer, so we are passing in an integer. And we'll use the variable of r again, because we are setting the radius equal to the value of our parameter. Okay, now we get to our utility functions. What are the things that we would want to know about a circle? Well, let's start with the diameter. We already have the radius, and we can get the radius using the assessor. So let's return the diameter. The diameter is simply twice the radius, so therefore it's going to be an integer value as well. And we call it diameter. We don't have to send in any parameter values because we're not sending anything into the class. All we're doing is returning to the user the value of the diameter. Now, I could create a variable here to temporarily hold the value of the diameter and then return that. We have a very, very simple calculation that returns a diameter, which is twice the radius. So I can actually do that on the return statement and return 2 times the radius. Okay, what's the next value that we want to know about a circle? Well, how about the circumference? Now to calculate that, we're going to be multiplying by pi. We are not going to be getting a whole number back, so we are going to be returning a double, a decimal value, and we will call it the circumference. Again, we don't need to send any value into the circle. We are simply using the value of the radius attribute. In this case, I will declare a variable, which I'll call circ, to hold the value of the circumference. Now, how do we calculate the circumference? The circumference is the diameter times pi. What's the diameter? 2 times the radius. Now we have to multiply that by pi. Now we could use the estimation of pi, which is 22 divided by 7. But let's get more exact, shall we? there's actually a class out there in the Java library called math, what's called a static class. The only thing we need to know about that at this point, we'll learn more about static a little bit later in the course, is that you don't create an object of type math. All you have is an object named math. It has a constant defined in that class, which is the value of pi, which is the capital letters pi. So we use that defined constant in the Java library. And then we just return the calculated value of the circumference to the user. Okay. Now the last circle value we defined in the lesson notes for this practice exercise was the area, which also multiplies by pi. So we are not going to be returning a whole number. Again, the area does not have a parameter being sent into the class. We're simply using the radius. So again, I will create a variable to hold the area. And how do we calculate the area of a circle? Well, it's pi times the radius squared. So we just multiply by the radius 2 times. And we'll return the area. Now I will save this, and it will automatically be given the name of the class when I save it. And I will compile to make sure I did not have any typographical errors here. And the compilation is completed, so there were no errors. Now this completes the circle class as it was defined in the lesson notes. But there's actually 2 other functions of a circle that weren't covered in the lesson notes, and I figure I might as well do them here. They are arcs and sectors. An arc is a fractional portion of the circumference, and a sector is a fractional portion of the area. What defines the fractional portion? An angle, which is made by 2 radii meeting in the center of the circle. And that angle is the proportion of the entire angle around the circle, which is 360 degrees. So let me show you mathematically what we mean by that. So we'll create a routine to return the value of an arc. Since it's a fraction of the circumference, and the circumference is not a decimal, not a whole number, it's a decimal value, we're going to return a double. So let's calculate an arc. We actually do need a parameter here. We need what is the measure of the interior angle. That's in degrees, so we'll get the value of the angle. That's our parameter. So now we'll create a value for our arc, our variable for the arc. Now, how do we calculate the arc? Well, it is a proportion of the circumference. So the first thing we want to get is the value of the circumference. And I'm doing this for a reason. We can actually call a method of this class inside of another method and get the return value from that. So now whatever is the value of the circumference calculated by this method here will be substituted in this formula when this Java statement executes. So that gives us the circumference. Now we want the proportion of that. What is the proportion? The interior angle divided by 360 degrees. So it's times the angle divided by 360 degrees. Now, this, as typed, will lose precision. Why is that? If you remember, division in Java is an integral operation. That means if both of the values involved in the operation are integers, we will get an integer value back. It will drop any fraction here. So let's not do that. So I will turn the value of the angle into a double by performing a typecast. To do that, I put inside parentheses right in front of the variable the data type that I am taking the value of that variable and converting. I'm not changing the data type of the variable. I'm just reading the value of the variable, in this case angle, putting that into a temporary variable, which the computer names. I have it named here in this method, and it turns that into a double value. And then when it divides by 360, the result of this division will be a double, and we don't lose any precision. That, therefore, is the proportion that we multiply by the circumference to get the arc. And now we just return the value of the arc. The sector will be the exact same thing. So in that case, I am simply going to do a copy and paste and change one thing when I do that. Instead of the circumference, I'm calling the area function. I'm taking the exact same proportion, but this time a proportion of the area instead of the circumference. Okay, now save this new version of Circle and compile this new version of Circle. As soon as the spinning circle is complete, compilation is done, no errors. So we can test this in the interactions pane. We will create a circle object. Fine. Now we will set the radius using the modifier function. Say 2. This illustrates something. I did it accidentally, but this is good. Notice we did not put the parentheses here. So it thinks this is an attribute that we're trying to change. So call the modifier, passing 2 as a parameter. Okay, that's the value. Now, with the value of that radius, let's go through everything and see what we get. So what is the value of the diameter? The diameter would be twice the radius, so it should be 4. But we don't see it. Why not? Remember when we worked with the interactions pane, if you put a semicolon at the end, it's being saved in temporary variables. To actually see the value, we don't want the semicolon at the end. That displays the return value of the method. And it says it's 4. That's twice the radius. That's correct. Now let's get the circumference of a circle with a radius of 2. What would that be? It's pi times the diameter. The diameter is 4. Pi is 3.1417, etc. So it's a little over 3. So we're talking about something between 12 and 13. That looks good. Now let's get the area. Now, the area is pi times the radius squared. The radius squared is, again, 4. So the area should actually be the same value as the circumference, which it is. So we know that our methods are working. And that is how you create a class from scratch. And the class we created was a circle class that was discussed in the lesson notes.